So we are going to now look at two fractions, and we're going to find composite functions for those two fractional or rational functions. And then we'll find their domains, and we'll see our domains a little bit different when we're dealing with those. All right, so let's start by finding f composed with g. And let's notice f is the first one in the notation. It is this one here. We're going to put parentheses for this x on top and this x on the bottom. So it's going to look like this. All right, so now g is second in the notation. I'm going to see if I can't just copy and paste g in. Let's see if I can. And just copy it and paste it right into the parenthesis. Oh, it may not. We'll see. Oh, yeah, it did allow it. Good. All right, now, except it put the comma, but that's okay. We know the comma shouldn't be there. All right, now, that's rather ugly. So we can't leave a fraction within a fraction like that. We've got to clean this thing up. And in fact, in order to find our domain, we're going to need to clean it up. So I'd like you to notice that there are little bitty fractions within the huge fraction here. And the denominator of the little bitty fractions is x minus 1. So what we're going to do is we're going to multiply this thing by x minus 1 over x minus 1. And realize by multiplying by something over itself, I'm multiplying by 1. So I'm really not changing this thing. I'm just making it look different. All right, so let's think of x minus 1 multiplied times this fraction 2 over x minus 1. This x minus 1 will cancel with the denominator of x minus 1, and I'll get just this 2 right here. All right, so first thing is I get that 2. Okay, so I've got my 2 now on the top of this fraction, and then the plus sign that comes right here. And here's what people want to forget. When we have this 2 right here, it too has to multiply by the x minus 1 on top. So really 2 times x minus 1, think of like distributing it through, will be 2x minus 2. All right, now let's do the same thing on the bottom. We're going to have this x minus 1 times this fraction. This x minus 1 will cancel with the x minus 1 in the bottom of that fraction, and we'll get just 2 again. But we can't forget this right here. We have a plus sign, and then we've got to multiply our 3 times the x minus 1, which will be 3x minus 3. Now we're almost done with this fraction. Let's just clean up the bottom and the top. So on the top, the 2 and the minus 2 will cancel, and I'll get just 2x. And on the bottom, I can add the 2 and the negative 3 to get negative 1. So I'll have 3x minus 1. And now it is finished, and we have our composite function. Now we'll go back and find the domains after we're done with all of these. So let's go to the g composed with f. All right, so same idea. G is first, so I want to put parentheses into g, into its x. So I'll have 2 over parentheses minus 1. Okay, now f is second. Let's drop f right into these parentheses. And again, I'm just going to try to cut and paste it, see if I can't just copy and paste it right in there. And there it is. All right, now we need to simplify that because, again, we have a fraction within a fraction. So our little bitty denominator, our smaller denominator, is the x plus 3. So we're going to multiply by x plus 3 over x plus 3. All right, so let's notice on top, when I multiply the 2 times the x plus 3, just think of it as distributing, and we get 2x plus 6. Not a whole lot of cleanup to do there, but let's look at the bottom. X plus 3 times the fraction is going to cancel with the x plus 3 in the bottom of the fraction, and we're just going to get the x plus 2 that's on top. And then let's not forget that the minus 1 has to multiply times the x plus 3, and think of it as distributing, so we'll get negative x minus 3. Now the only thing left to do is to clean up the bottom of that fraction. So let's notice that our x's will cancel on the bottom, and 2 minus 3 will give us a negative 1. Whoops. Negative 1. And really, when there's a negative 1 in the bottom, we can think of bringing it to the top, because a 1 in the bottom really gives us a whole number. So this becomes negative 2x minus 6. It just changes everything into a negative. All right, so that's that one. Let's go to f composed with f. Now this one could be quite ugly. We're going to take f and we're going to put parentheses into both of its x's, just like we did up in the first one. So there it is, parentheses plus 2, parentheses plus 3, and then f is second in the notation, so we're going to drop f into both parentheses. So again, I'll do this by copying and pasting. Copy that, and let's drop it into the first set of parentheses. Well, somehow I got the equal sign, but it's all right, I'll get that out of there in a sec. I think I can get it out of there. There we go. All right, now, again, we've got little fractions within the bigger fraction. We need to get rid of the little fractions. So let's notice that they both have a denominator of x plus 3. So we're going to multiply by x plus 3 over x plus 3. So let's note what we have. When we take our x plus 3 and multiply it times this fraction, it will cancel with the bottom of the fraction. So we'll get x plus 2. But then we also have to multiply the x plus 3 times this positive 2. So distributing the 2, we'll have 2x plus 6. Now let's do the same thing on the bottom. X plus 3 times the fraction will cancel with the bottom of the fraction, so we'll just get x plus 2. But now we have to multiply the x plus 3 times that 3, which will be 3x plus 9. And now let's clean up the top and the bottom. Oops, equal. So add the x's on the top, and we will have 3x, and our 2 plus 6 will be 8. And on the bottom, we'll have 4x and 11. And we're done with that ugly thing. Okay, so let's do the last of these, and then we will take a look at our domains. All right, so now we have g composed with g. So we're going to put parentheses into the x here. So we'll have 2 over parentheses minus 1. Now g is second in the notation, so we're going to plop g into these parentheses. And again, I'll just try to copy and paste it. So copy that and paste it. All right, now, again, we've got to clean this up because we have a fraction within a fraction. So we're going to multiply by the little denominator here, x minus 1. So we're going to multiply by x minus 1 over x minus 1. Okay, so on the top, we've got a 2 times our x minus 1, which will be 2x minus 2. On the bottom, x minus 1 times the fraction will cancel with that denominator, and we'll just get that 2. So we'll have 2. But we can't forget, we've got to multiply this negative 1 times the x minus 1, which will be negative x plus 1. And now let's add like terms on the bottom, nothing to do to the top. So our top will remain the same, but let's add like terms on the bottom, and we will have negative x, and our 2 plus 1 will be 3. Okay, now we've got all of our functions. Let's go to finding their domains. Okay, so remember with fractions, we have to look at where the denominator of a fraction is equal to 0, and we have to exclude that from our domain. So let's remember from our last video, we first look at the second one in the notation and we see what its domain is. So the second one in the notation is g. We need to look at g, and let's notice where the bottom of this fraction would be equal to 0. At x equals 1, this denominator would be equal to 0. So we can't have a 1 in the domain of our function. And I'm just going to, like, right beneath this, put what we can't have. We cannot have, I think I have a symbol for not equal to. We cannot have 1 in g. All right, that belongs to this right here. So x can't be 1. All right, so we also, though, when doing the domain, have to look at our final answer, and we have to look at where this denominator would be 0. So to figure that out, we can't just look at it quite as easily. Let's just solve the equation 3x minus 1 equals 0. So if I add 1 to both sides, trying to get it out of this box, but maybe I'll just use my, no, I don't have a draw feature for some reason on this computer. All right, so let's solve it by adding 1 to both sides. And I just have to kind of do it down here. So I apologize that it's so far away. It's kind of acting strange, but that's Word for you. 3x equals 1. And then let's divide out our 3, and we'll get x equals 1/3. All right, now, there are two places then. We cannot have x equal to 1, and we cannot have x equal to 1/3. So our domain here, we're going to leave out the 1/3, and we're going to leave out the 1. So from negative infinity up until, I'm just trying to find my little infinity symbol here. Negative infinity up until we reach 1/3. And then the union symbol means also. Looks like a U, but, and then really should do a capital to make it look right. There we go. And then from 1/3 to 1. And then finally from 1 to infinity. Okay, or depending upon what my open math is asking for, we can say x not equal 1, x not equal 1/3. And remember that the interval notation is leaving these numbers out if this is an open bracket. All right, so let's go to G and do the same idea. So for our G composed with F and do the same idea. So F is the second one in the notation, so we need to look at F's domain. If we look at the bottom of F, -3 can't be put in here. So x can't be equal to -3 for this function right here. Okay, now let's look at our final answer here. We'll notice that G composed with F does not have a denominator. So really the domain of this piece would be all real numbers. So the only restriction is that we can't have an x value equal to -3. So our domain is negative infinity to -3. Get my little infinity symbol again. Along with -3 to infinity. So everything but the -3. All right. So let's go to F composed with F. Okay, so notice that F, again, is the second one in the notation. We've already said that we cannot have, oops, sorry, wrong one, -3 for F. So now let's look at the denominator of this, and we've got 4x plus 11 that we've got to set to 0. And if we subtract 11 on both sides, we'll get 4x equals -11. And then divide by 4, x is -11/4. Now, just to write it differently this time, I'm just going to write the domain in this manner, just in case you have to do some of this in homework. X cannot be equal to -11/4, and it can't be equal to -3. All right, now let's go to our last one. G is the second one in the domain, or in the function. G can't be equal to 1. Setting this denominator to 0 and moving the x over to the right, I get that x can't be 3. So for the domain of this one, we've got that x can't be 3, and it can't be